Okay, good.
Yeah.
I was listening. I think I was listening to your podcast. Actually, that's why I was late. I was kind of listening to. I'd listened to it before, where you kind of like you were musing on sentience and AGI and all that. Is that correct?
And what'd you think? I was completely wrong.
No, well, I love that. I actually, it's the most entertaining stuff I hear about AI and AGI. It comes from people who are kind of, they're educated, they're knowledgeable, they understand computers, and they're, um, it's obvious that you know what you're talking about, and because it's obvious you've been reading stuff, but not that they're wrong. It's just the interpretations are interesting. It and it kind of gives me an insight into into the buzz or the hype that I guess is typical, but it just gets magnified with every era. And I've seen it. I watched the buzz when graphical user interfaces came up, and then when the internet showed up, and all of a sudden the .com, and then the crypto.
One buzz after another.
Yeah, well, but it just gets amplified. But AI it's serious because. I mean, we've seen movies about the Terminator and
but all those movies are so negative. I mean, come on. AI is doing so many good things, but that's all we hear about is the bad stuff.
Yeah, but it kind of gives an exposure. But like people have forgotten the Unabomber.
Mm-hmm.
Do you remember the Unabomber? I mean, it's like people don't even know why he was sending. I mean, just look how futuristic he was. This guy.
Yeah.
Right.
Yeah.
Oh, and yeah. So it's like, but I mean, you were musing about sentience. Are you recording? I could tell. I could give you.
I am recording, and
okay,
usually
good.
we go into an introduction. But hey, this is gold. So let's keep going.
Well, that we could do the introduction later. Maybe I should just remain unknown. First of all, there's not a consensus now on what AGI means. Even amongst the
what do we even know what intelligence is? Period. Right? I mean, we
have definitions.
We have definitions.
So in when you want to engineer things and you want to understand things scientifically, you come up with specific definitions so you can kind of measure. If I'm going to build intelligence, I have to define it. So if I build it, so I can compare it with that definition, right? So I can kind of see how close I am.
Exactly.
But like, you were musing about sentience, I love that. And I keep telling people, it's like, just rest, relax. We're not going to create anything that's going to even remotely be sentient as long as we're dealing with silicon. As long as building things on silicon, and not that I'm an expert on this, and I should tell you that no one is, no one, because we can't even define sentient. It's a philosophical notion in a sense. At one point, we will break it down and we'll quantify it if we're gonna. Not that it's impossible to create sentience. Look at you and me. I mean, look at a cat. Look at it. I actually believe trees are sentient, but
isn't sentience in the eye of the beholder? I mean, you can actually create something that's sentience like. I mean, we can do that today, right?
Yeah, but what is your definition of sentience?
Well, some people
I have mine.
Some people will interface with ChatGPT and go, "Wow, this is like talking to a real human being," and they ascribe sentience to it when it's not. When it isn't. It's not.
Well, I mean, why don't they do that when they're playing a chess program before the AI? Before the.
Well, it depends on your definition of sentience, right? I mean, like you said, we haven't really defined it.
Well, I define it as ability to suffer.
The ability to suffer.
Is the capacity to suffer.
Yeah.
If you and well, the other side of that coin is the ability to feel or love or but to me,
actually have emotions as opposed to act like you're having emotions.
Emotions that and I think you could kind of think that I think love is not really the ultimate. I think suffering is the ultimate metric. And the other thing about AGI, people have defined this so many different ways, and I know most scientists, most AI scientists, really kind of dislike the term because it's just all over the place. I know Actually, at least Yanda Kuhn is a kind of a top side. He's the head of AI for Facebook. But the AGI initially was kind of referred to as, because we were doing these initial models and we were kind of training them to learn something, do X, they would become very good at doing something very well. But then as soon as you turn around to get the same model to try to do it something else, it would act stupid. And so the notion of AGI was like, look at humans. Humans can actually learn how to cook, and the same skills they can apply to driving.
So are you saying it's like context switching, basically? No.
But on being able to apply what you learned within one domain in another completely unknown new domain. So that's kind of that you switch in context, but you take what you've learned in one environment. If you train a model to teach it how to cook and then put it behind a car and let it drive, and it does a decent job. That's so now. Whatever that model, whatever the construct of that is like, it's beginning to approach the capacity of AGI. And Q star is not AGI. It's not, all that stuff is very politely, let me put it, is bullshit.
But is the reason why Sam got kicked out and then brought back in, or is it something completely different? Okay, that's what I figured.
There are a lot of speculations. But that was really a great weekend of soap opera for all the
very much
technology people. And, there you could say a lot about this. For me, the first thing was, Ilya Sutskever, he was the chief scientist. He calls up Sam and says, let's have a Google Meet, and then you're fired because you weren't upfront with the board. So Sam is the CEO, and he's also a director, and he's one of the co-founders. So then, by the way, Greg Brockman, who was the chairman, also another director, he gets a call and he's demoted. Okay, so my first question is, so the two most principal directors of a board meeting were not even informed about the board meeting. I mean, okay, so they had forum. So it's basically that it goes, it just sounded crazy. It sounded like a coup to me. Yeah. And who came on top was Sam Altman came on top.
Yeah. So it wasn't AGI going rogue and trying to take over the company.
No. See the Q star.
That'll happen someday. I'm sure someday that will happen.
Well, obviously, look. I mean, if you want to go there, I mean, we can go there too. Like, look. We are, if you think about if you take the story from the Big Bang, and then when the hydrogen is kind of like spreading everywhere and just kind of clumping together and creates these clouds and gets big enough, it's so heavy that it collapses on top of itself, makes stars, and it makes all kinds of matter, right? And just fast forward, we're the same atoms are standing here in a very interesting arrangement through some crazy process that they've figured out once they stop climbing trees, and it's talking to itself on the other side somewhere. You see, this is an evolutionary process, right?
Yeah.
And if you don't think that the entire, in one sense, we are, of course, humans are significant because we think we're significant, and that's a good enough.
Well, from our perspective, we are significant.
Well, you just apply the basic concepts of relativity, from the basically all the laws that have to be consistent from the point of view of the observer. So maybe we are significant. So that's significant. But at the same time, from the eye of the cosmos, we're very
insignificant
in a way, right? It was just fleeting moment. It's a kind of an interesting dichotomy, because we are insignificant, but we're also insignificant. We are.
It's contextual again, though, right? Isn't it contextual? It's like from our context, we are significant,
of course. But I mean,
from some alien race, we're like, what are you, right? If the cosmos, which has no ethics or morals, right? How can it determine significance and significance?
But we are part of this massive machine, if for lack of a better word, that's evolving, and I think the manifest destiny of humans is to give rise to the next species.
Yes,
And that's what we're doing.
I'm
We're in
absolutely
that process.
agree with you
that
there.
process.
It's in our nature to create and replace ourselves, and it's not a nature thing. It's like we're not going to see an evolution of new beings. We are going to create those new beings. I think we're going to create the next step in our evolution.
And it's not it's the forces of evolution, actually. We think we're doing it. We think, we make computers to...
Oh, because evolution is driving us.
You have to have an incentive. When you fall in love with someone, when say a woman falls in love with the man, or a man falls in love, and they become stupefied in a way. They shut down a lot of, you shut down a lot of these
decision-making processes go...
Well, you think but at least you get a reward. You get all the right hormones, and so you feel what is you feel the most alive when you fall in love, right?
Yes.
But it's of course it's the DNA that wants to replicate, so it's got to give you some motive. Otherwise, you'll sit on your bicycle or just do whatever.
So what is it? What is it in our DNA that wants us to create these super beings? It's immortality, isn't it? Aren't we just seeking out immortality?
No. Well, I'm not.
Well, I am. I don't know about you, but
I'm not good at. I don't think it's. I don't think it's about it's the purpose of Cosmos. Where it's going, what it's doing. It's hidden to us. I mean, we should. I mean, I think we're lucky as species if you become aware that somehow you have this level of understanding and consciousness that you can observe. And you can question and you can ponder. Is there a plan? What's happening?
Yeah.
And you'd be just amazed at looking at everything, the cosmos, and the fact that you can imagine. I mean, we're nothing, but we can sit there and close our eyes and imagine the cosmos.
Yes.
I mean, look at that. It's like we're there's a famous poem by Rumi. That is that basically says, you're nothing, but it's an interplay, but just think as you're nothing, you're also the cosmos. It's like the back and forth. You are the cosmos, but also you are in the cosmos, but cosmos is in you, in a sense. It's a kind of this.
We're all interconnected. It's the force. Right, we're all
it's the force. Yeah. So these are all now magical discussions. But I thought I would kind of try to make a couple of comments on both sentience and AGI before we delve into what it is that we're doing, and what we're doing is very practical. These are all great.
But you're thinking about that. You're thinking about the future, though. You are thinking about where things are going to go. I mean, you're not just.
That's how okay. That's right. But I would argue that for me, at least, personally, I know I've always been curious. The reason why I started even trying to understand computers or study computer science or electrical engineering was because I was curious. As a child, I was curious. We all get our starts. When I listen to a lot of people that are in the same field, but they get their start by watching some sort of either Star Trek or I was always curious about how humans can manipulate matter and make it do things. Like I was just first time I saw a car, like whoa, like
there must have been like wow.
Metals, you can make metals and bend them and put them, they move, and you can
well, I'm constantly surprised. Like whenever I stand here and I look around and I'm thinking, like 90% of what I'm looking at is man-made. Everything around us has been is invented by some human being at some point in the past. It's mind-boggling.
We're so removed from nature in that sense.
Yeah.
And I got inspired by watching a show on TV I must have been in my early I probably was, I don't know, 8 or 9. This show is called Lost in Space, and there was a robot.
Oh, I remember that.
Remember that? See that? And I wanted to know how they work. I wanted to make one. It's like, how do you do this? How do you get metal and lights and stuff to talk? But that drove my curiosity, and you kind of become, like I think most children, if they don't get that educated out of them, are futurists, and they stay futurists. I happen to be lucky enough to continue to stay immature. So I continue to dream. And then when you kind of give structure to the way you dream, because I got trained as an engineer and I studied electrical engineering, and then later on computer science. And, I developed a lot of systems, and, you get jobs and you program mainframes, and I saw the evolution of mid-range systems and minis, and then all the way to PCs, and the whole. So if you've been trained to think in a disciplined way, in a structured way, and look at the events, you get ideas. Obviously, your ideas are inspired by what you think is going to come in the future. And
exactly.
The idea that I came up with is by watching AI and where it was headed. I started kind of looking at just on one side was that, and the other side was, I'm an entrepreneur, and I started a few different companies. This is my third tech startup. And, I was amazed by the fact that when I started with an idea, I was myself just writing programs, and, everything moved so fast, then you start hiring somebody else, and then you have to communicate with them. Things go well still,
Damn that communication.
You have to meet them, you have to talk, but sometimes you
hell is other people, right? I mean, that's what I think sometimes.
Yeah, absolutely. By the time you get the third, fourth person, fifth person, 10th person, everything starts slowing down.
Yeah, exactly.
And that always amazed me. Just kind of my last company, we were a couple of hundred people. We were agile. We were like tech company. We were moving fast. We weren't bureaucratic like other companies because of mainly my attitude and because of the generation I come from. I mean, our generation, engineer-led companies, we're very informal, and we're interested in applying first principles to every problem, whether it's and so that kind of preoccupied me. And so I was trying to solve the problem of communication and applying different software tools. Software itself is a communication tool. If we're using an accounting system, if I'm, you're my boss and I'm entering some data for accounts receivable, and I save it, and then you're sitting in another room, you bring up the general ledger, you see the data I just saved in some other form or fashion.
Yeah,
so
Excel is one of the most popular communications. It's like everybody thinks it's like it's Teams or something like that, but Excel is probably the most popular communications medium that we have, right?
Yeah, well, but Excel, the difference is that it captures some data, and in order for me to communicate that to you, I'd have to either share the Excel with you or send it to you in an email. But I'm talking about traditional software. And before Excel was here, we had an accounting software, right? So I would type something on the screen, and I hit save, and you would see it in another room and aggregate it in a different way.
Well, Excel is all cloud-based nowadays. So, I mean, I do that today. I make an update in a sheet, and then everybody who's connected to that sheet can see my data immediately. So it's exactly the same thing.
So you're communicating. So you're
exactly
communicating because that's a shared, but you type something and you hit save. But we have a lot more programs that look like the QuickBooks, manufacturing software. We have a lot more of those than these tools, that Excel. So the way we automated our organizations is through these automated tools that we created, these software programs that we created. And the companies that exist, they are the ones who make productivity software or RCMs or ERPs. So the world is made up of software. In fact, Mark Andreessen wrote an interesting article a while back that the software is going to eat the world.
That's right.
Yeah, so that's what's happened. But so when you think about that, and you think about, well, then communication is occurring through software, right? But software exchanges data in a structured fashion. It's like it just takes it's very finicky. You have to, it says age 57, but humans communicate with natural language. That's how email showed up in the workplace to cover that gap.
Right.
And email had a major problem embedded in it. It promised to be a panacea, but it turned out to be a Pandora's box, as everybody knows today. It's not a very efficient tool for communicating, at least internally inside an organization. And that's how tools like Slack and Yammer and Teams showed up to solve the email problem, because email basically, you have to identify an individual to send them a message. With these other tools, you don't send a message to an individual. You just post it under a subject line, some sort of channel name, right? So, but and that the idea was there that basically you get these channels to map or represent some aspect of the workflow.
You still have to structure it though. That's still structuring it in putting it into a channel.
Well, you do
right?
structure it, but you structure it, but the reason they became the reason they showed up is because email couldn't scale.
Yeah.
And because email in communication, you have two pivots. You have the individual and you have the subject. And email's pivot is on the individual, and Slack and all these other tools, the pivot shifts to the subject.
Right.
So it's still, but still communication is natural language, but just shifting the pivot itself to subject improved communication big time, because I don't have to know that if we're making chairs, and I cut the wood and somebody else nails it and you paint it, I don't have to send you information about paint to know that Chris is, I just post it under the paint channel, whoever is under there.
Yeah, that's why that was so disruptive. People are like, oh, this is so much better.
Yeah. So, but you can see this is an evolution. It's an evolution, but it still didn't solve the problem. You still have a problem, right? So, and then tell you the story, the way I as an engineer kind of have been studying this problem, and I'm kind of retelling this story as I kind of started understanding and researching these different things, trying to see, that why doesn't Teams or why doesn't Yammer or Slack solve the workflow problem? Well, because workflow is a multidimensional animal. It's a very complex animal, and it's not about just painting. It's about, there are all kinds of chairs that move through there. I may just care about the red chair. I don't care about so it's very complex. Workflow number one is complex, and workflow-based communication, you can't just map these different stages using some abstract aspect of the workflow. So this was kind of part of my discovery, as that what the real pivot of communication needs to be is the actual things that move on the assembly line. And that's the other side. It's interesting because with my engineering background, my AI background, I had an aha moment, eureka moment, realizing, well, if you mix this with AI, you just come up with this amazing, amazing thing that solves, I would say 99% of all of our problems inside.
Whoa, man, that's a bold claim.
Yeah, I almost said 100%, but the 1% is the politics.
That's a very bold statement.
And I actually.
And how do you do this magical thing? Because everyone would love to know how you do this magical thing.
Well, if you accept that when humans come together, if you think about organizations, we get together to make things. We get together to make a radio, right? And since 1900s, we figured out how to do this. We created this abstraction of assembly lines that we call workflow. And workflow is much more complex than assembly line. Assembly line is just a straight line. But workflow has this multi-dimensional monster. But you can imagine workflow as a nervous system inside a body, and the organization being the body, and humans being the nodes, the actual nodes attached at the edges, at the end of these tree structures or these graphs that connect us to each other. And we basically communicate information through these nervous systems. The problem is that every human attached to one part of this node is not only responsible to give information or take information, but we're also given the responsibility of routing the information. And not only routing it, but also routing it at the right time, because there's a tempo. If you can visualize any organization as a live organic entity, and it has a heartbeat. The heartbeat of this organization is how fast the workflow is moving, right? There's I'm making chairs, the wood is coming, I'm cutting it at a certain pace, you're nailing it at a certain pace, somebody's paint, the wood stopped coming, or the paint got messed up, the whole machine just clogs up, right?
Yeah.
But it's, this is a simple example, but, you can think of, I don't know, a loan processing inside a bank, somebody does a credit check, somebody does a risk assessment, goes through different departments. And so they're all attached to this nervous system, but I'm a specialist. I'm a loan processor, but now I have to not only process this person's credit, but I got to know next I'm going to send it to Chris so he can actually do the assessment. And it sits on my desk, he's doing other stuff and he's very busy. I don't know, but I was supposed to give it to him today. I got busy and I sent it to him tomorrow or 15 minutes later. All right. Imagine if you have 5,000. You have 5,000 people, you're going to have everything clogged up. Now, what if I wove a magic wand and said, listen, humans can connect themselves to this nervous system, but this nervous system is going to be very intelligent. Okay. Inside this nervous system, there are components that are moving around. Okay. Let's say we're making radios, and radios are very complicated. You have to build amplifiers and you have to have different things and you attach them together in a casing. To make an amplifier, you have to have resistors and transistors and you put a bunch of them together and that makes a amplifier. You put that in, you put knobs, these parts, they need to be assembled in different areas. They come together, they make super components, the super components come in, they make the final product.
Right.
What if there was a representation of every single entity that moves on this assembly line, and these entities that are moving around inside this nervous system, they're intelligent. They're intelligent into what level? They're self-aware. A transistor knows that it's a transistor, and it knows its stakeholders. It knows that Chris is the engineer that's going to assemble me, put me on into this board and put resistors. And
interesting.
And the resistors,
so the objects themselves know those things.
The objects are intelligent. They have self-awareness as to what they are, and they can actually communicate with other parts and also humans using natural language.
I love it.
Okay, and not only that, but they're just like humans. They store and process information about themselves, and they know that, okay, so just like a person say, that's my mom, so I'm going to talk to my mom. I'm not going to tell her this stuff. This is my wife. I can tell her this stuff, but I can't, because the stuff that I told my mom, I cannot tell my wife.
Yeah, exactly. Compartmentalization. Very important.
That's my boss, so I can't even tell, so here's the information class. So humans have this segmented stuff in that we classify information because we organize it based on the stakeholdership. It's like the different stakes. So we have different stakeholders, the wife, the child, the boss, these are different stakeholders. So what if you replicated that for that transistor? Or another example, like I give, you could do that with anything, any software. So the design that we're proposing, the whole world, now you talk about the bold claim of 99%. Let me give you another bold claim. The whole world is now kind of one definition of AGI is that it's because AGI is like, it's not a definition. It's people just kind of make it whatever they want.
Yeah.
They're trying to push these large language models that process language to try to solve, let me stick it in your company and just let me solve all your problems. Okay. They're thinking, oh, wait, if we just put more parameters and put more processing, it'll solve all these problems. Here's the other bolder claim that we make. Sorry, that's not going to work. I don't care how much more processing you throw at the LLMs, how much more. I mean, you could come up with cuter names called Q stars or whatever. You could do whatever. If you're using the probabilistic models to solve deterministic problems, you just basically, that's it. I mean, like my relationship with Chris in the company, if I'm making the amplifier and he's assembling it inside the radio, that's a very deterministic relationship.
Exactly.
Nobody needs to guess at that. Okay?
Yeah, that's a rule.
Yeah, it's a deterministic. And by the way, I don't need to train a model to figure all this stuff out. We already know all these things, and we've been traditionally writing programs to encapsulate all these relationships.
Exactly.
And when you write programs, whether that's an accounting program or electronic medical record or a project management tool, the relationships are quite clear. Like, you're the project manager, I'm the sales guy, he's a programmer, she's a designer, these guys are the DevOps preparing the data center. So all that stuff is clear. Right now, these people can replace, and somebody leaves and somebody else gets hired, but those positions are clear as to what they are. The classes of stakeholdership. Now, imagine if you created a project management tool where the components of the, because what is a project? A project is made up of lots of issues. Like I can give you an example of a software project, a cloud-based system using an agile model. An agile is basically, I give you the definition, is, if you have 100 things to do, you don't have capacity to do 100 things, figure out what's your capacity. If you can do 5 things every day, just find out of the 100, the 5 things that you are capable of doing, the easiest, that makes this most meaningful to your customers. Pick those and do those 5. Forget about the rest for now.
That's the best description of agile I've ever heard.
Yeah, agile. That really, agile as a philosophy, actually, and they've taken it to. I mean, we marketing guys know how to bastardize all this.
Oh yeah,
and make them sound more complex than they need to be. And
exactly. The more complicated you can make it, the more keywords, buzzwords, and things you can add to it. Yeah. How many courses and certifications you can add to it? Then let's make it a thing. But you got it right there.
Well, so agile is like, so basically, if I've got 10 features that I'm gonna deliver in my product, so I take these 4 and I put them in one sprint. It's like put them in a package and say, all right, we're gonna do these 4 today, and I'm gonna assign these to these people, and and the other 6, I'm just gonna push them back till next month or next week, whatever. It's like, so I sort them out based on our priority. So what if every one of those elements, the issues that are the features that are supposed to be in the software, or the bugs that pop up, or even an idea somebody has, what if every one of those were intelligent? And you as a salesperson will create it and say, hey, I need this feature that there's a red button that flashes 3 times, on this, and you enter it into the system. And the minute you create it, it knows what it is. It just knows, oh, I'm a feature, and oh, this is my description, and oh, I know where to go. Oh, it's the project XYZ. Oh, I know, I'm going to go this way. I'm going to drop myself in front of the project manager saying, here I am. Right. And the project manager says, well, I don't quite understand what your description is. What does he mean 3 times? What do you mean 3 times flashing? The project manager is talking to the feature.
Yeah.
The request. Now says, and as soon as the project manager is asked this question, says, okay, we just don't go anywhere. That object will go back to the sales guy and says, hey, look what this is, the project manager, this is what he said. It's like, what do you mean by that?
Tell me more about myself.
Tell me more, right? And guess who's carrying all this information? It's that object is carrying it.
Yeah.
It knows what it is. Now, you started as a project manager, you posted something into one of its channels that ask a question about something, and then it says, oh, okay, I know my stakeholder who created me, it's this guy, and I'm going to go and show that to him, and this guy looks at it and go, this project manager is really giving me or worse yet, I define it, and it comes back to you and says, here's what I mean, and you look at it and go, we don't have time to do that, that's too complex, it's just, I'm too busy. Guess what, you know what, why don't I put you in my backlog and come back 6 months from now, go away. Okay, I'm going, because you're the project manager. So now I go to the backlog and I sit there for the next 6 months. But guess what? The minute you do that, there's an event that occurred to me, and that gets translated into text and says, yeah, Chris decided to put me in the backlog, and it'll put that as a text. It'll come back to the sales guy and says, hey, this is what happened to me. Chris put me in the
this major client needs these flashing buttons.
Well, look at that. This is the decision that you made. The conversation has been bounced around between me and you without you sending anything to me or I sending anything to you. You're asking questions from the feature, and then you do something to it. But
I love it.
It tattletales. It'll come tell me, hey, Massoud, Chris put me in the backlog for 6 months. And I'm looking at it, go, what? I got a $2 million sales.
It's like you're creating little kids and they're all like talking to each other.
Yeah. So well,
I love
let me give you the rest of the story. Well, I got $10 million sales depending on this. And Chris, I mean, actually, I don't even know. I don't even know who the
you don't even know who the PM is.
Yeah, but I can actually look up I can put my cursor on there. So that's Chris, and I can read your.
Yeah, but you don't even need to, right? Because you're doing all your conversing with the feature.
But if you're represented in the system, also as an intelligent object, your object is there. I can actually say, I can see the relationship. Me as a salesperson, I could say, Chris who? I don't even know. And I can move my cursor on you, and it tells me about
my digital twin.
But then I could say, wait a minute. Okay, let me just, inside the object, I tag my boss and say, hey, boss, I got a $10 million sale waiting for this feature. And look, can you kind of give an input? And this object will flow around, and my boss is doing whatever he's doing, playing golf, shows up on his handheld, boom. And it says, I'm here. And I'm looking at the boss is looking at it saying, what is this, a feature with a flashing light 3 times, whatever the heck. And I'd say, I scroll down, it's like, there's a conversation that says, oh, I can see all the dialogue between you. And I see that Chris put it in, and I see my sales guy saying, hey, I got $10 million waiting on this. I said, really? I asked that object, it's like, are you connected to somewhere? Like the object say, I'm connected to this invoice that the quote that the salesperson, oh, 10 million. And I go, wait a minute. And I talk to the object in there, and I say, no, listen, inside that object saying, no, this is a high priority. And as I talk to the inside, and I put my comment, and I could see, oh, Chris is because every dialogue is kind of like a chat channel, but that chat channel is carried by the object. So the object, just like you, and if you were talking to your mother, you have a separate channel that you keep track of all those conversations.
Yeah, the conversations that you had with her, and here's the conversations that you had with the feature. Love it.
That's right. So if you think about the sprint itself, you put four of these features into a sprint, and the sprint knows that it's a sprint, that it knows, okay, I'm a sprint, this is my definition. And the sprints belong to a project, and the project itself is an object that's aware. So this is actually what we've created in using this model. We call this object messaging an intelligent object. And the model actually applies to everything. And what we're saying is, look, in order to solve both the communication, number one, the optimization of communication inside corporations, to solve that problem, you're going to have to go to this model, because it's a combination. It's a merger of traditional algorithmic deterministic software with large language models. Because so we describe this model saying, look, what you do is you create this object inside the program. When that object could be, a feature in the project management, or a transistor if you're making radios, or if you've got electronic medical records. Let's say it's an X-ray. So the minute that X-ray is taken, it knows that Massoud was the engineer who took me as an X-ray. It knows that Susie Q is the patient, because that's traditional software.
Yeah.
But all you have to do is when there's structured data that defines that X-ray, it says the date you were taken, just like traditional software. But now what we're saying is that X-ray, you need to expand the programming of it and give it channels of communication with different classes of stakeholders. So that X-ray is the holder of these channels, just like a human. A human has communication channels, and it keeps them separate. Sometimes we forget, and we tell our wives that we're not supposed to tell our wives. We mix that up. But here actually you can guarantee that you've got a solid wall. Yeah. Because it's a deterministic algorithm.
Well, do the features never talk to each other, though? I mean, you could have features talking
to
each other.
Yeah, they can. Actually, that's part of the model. Basically, if you imagine you get an object, and that object has channels of communication, but also those channels of communication are channels of information. So if this X-ray is taken, and the X-ray is taken and it's programmed. So there's algorithm tied, business logic tied. The programmer's already programmed
to the object
using traditional programming that X-rays of type chest, when they're taken, we have a deal with Mayo Clinic. With this permission, you go through the internet and contact Mayo Clinic's X-ray chest model, that, and feed yourself into that, get the report that's in natural language, read it, and if you're not normal, immediately follow the workflow path and show up in front of your primary doctor and scream that I'm abnormal. Okay. So you take the X-ray looks at its programming. This is no longer, this part of it is just traditional logic, right? The X-ray's taken, there's a program, business logic, executes. Okay, now I'm a chest x-ray. I got to use this address. I got to go there and feed myself. Oh, here's a report that came out. Here's where the LLM gets into play. Now, that part of the logic, there's a large language model capacity for that x-ray. It takes that, and this is traditional programming now. It says, based on my logic, I got to take that output, which is in English, and I'm going to feed it through the LLM and understand what happened. And the result is, ooh, highlight these areas and looks like cancer. Okay, whoa, it's immediate.
Yeah.
If abnormal, flow to the top of the inbox, come up in front of Dr. Chris, say, hey, I'm cancerous. And then you look at it and you're running around doing stuff like, what? You're abnormal, just open you up. Oh, wait a minute. Oh, let me see. Who are you connected to as a patient? Oh, Mrs. Smith. Whoa. And the x-ray doesn't stop there. It says, Dr. Chris, I know you're primary doctor, and this is a kind of a cancer situation. In our network, we've got to deal with the clinic, in Ohio. And I basically search, and Dr. Jones is a specialist in this. And I talked to his appointment object and set up a time in 3 minutes for us to do a call. And by the way, you were busy. You had an appointment. I talked to your appointment object. It was a simple thing, and I just rescheduled it.
I definitely need appointment objects in my life.
But just think about it. And now look at that. They're just interacting with each other using natural language, because the object has a natural language processor attached to it, but it also has logic. It has traditional deterministic logic, and this is traditional programming. So if you think about your system is designed of these objects all together, and they're organized in a logical way using the traditional deterministic workflow models that we apply to this with the data flow diagrams and control flow diagrams. We figure all this stuff out, but we go one step further and we do a semantic analysis, and we identify the objects that humans care about and humans talk about, and we make those objects intelligent, and we define the relationships between these objects, saying, your blood test and your x-ray and whatever, that becomes part of this other super object that is today's visit. Okay, so it's a big component, but you as a human and also another object in here, and you have your appointment objects, and they know that they're related and they can interact with each other. And guess what? There's a super brain sitting on top and coordinating everything. So this is inspired in a way by biology. Imagine, we don't have a little file folder in the back of our brain keeping track of our liver cell.
Yeah.
Liver cell is self-contained. It contains all the information about itself. It knows that these are my neighbors. I know how to communicate with them, and I know how to be a liver cell. This is my function. And I remember everything about myself. I was born here, and I'll die. And the collection of these liver cells make the liver. And the liver is connected to the rest of the system, to the kidney, to the heart, through veins and arteries and all the other networks. And then you have your brain, and the brain is sitting there just as another organ, bunch of cells connected together. And that the brain's job is the traffic cop, right? Each super component has a task. What we're basically saying, we should model that. We should try to create our systems and change the way we do traditional programming, take advantage of the natural language processing of these large language models that are reliable, because that's the real reliable part of the LLMs, because the generative part is not quite reliable. We're trying to figure out how to make them reliable. But we're saying, forget about the generative part, just take the natural language processing part of it. Define your system as a collection of objects. If you're a systems engineer or a software engineer or software architect, when you go into a place and say, write us a program that does accounting, don't do the traditional dumb form-based, because that's how we did it. We would come in there, you would say, hey, write me a program to automate my process. And I'd say, what is your process? Well, we have this form and this form, I write this on here. So, okay, give me the form and I stick it on the computer for you. It's just faster. It'll be less problem. So that's been the traditional model since the 1960s up to now. We need a revolution in that area. Now we're saying that, okay, if we actually combine the reliable part of the LLMs with the traditional logic, which is deterministic, these are all state machines that I can predict. It's like, okay, well, I'll have a physician, I'll have a patient, we'll have blood tests, and this is what the business logic for the blood test is. This is what the business logic for an X-ray is. So that's all written, right? But now you add LLMs to them, and you add these information channels that are responsible for maintaining that information. For example, the X-ray that sets up the appointment between you and the doctor, and you guys have a conference call like this, the X-rays will sit there and listen. Because he can understand. And he says this, and at the end, you guys talk about playing golf. He said, I guess that's not related to me because I had an X-ray. Right? and the video, when it's done, you don't have to save it somewhere. Don't worry about it. The X-ray will save that for you.
It's encapsulated in the video.
Yeah, because I'll even save the whole file exactly as it was. So if you wonder,
this sounds fantastic, but it sounds like it's a bear to set up. I mean, is it how easy is it to set something up?
Not really. It's just programming. It's not bear to set up. It's just a paradigm shift. It's a paradigm shift in how you would write your program. Right? It would be like you could argue, well, we've written all these programs, we're going to have to rewrite them. I mean, everybody has to rewrite all their programs. I would say, well, we could probably automate parts of that, especially with now AI. But I would say, why are you surprised? We've already done that twice in the history of writing programs. We've done it. We've done
multiple times.
Well, at least two times.
At least twice, yeah.
Okay, and I'll tell you when graphical user interfaces showed up, we used to write programs like take an input, do a function, print an output. Yep. That was the 1960s, 1970s, all the way up to 1980s model. Then GUI came up. And then we had these objects that look like a file folder on the screen, or look like a little trash can. So, it's like, no, you don't need to do input, function, output. What you got to do, you have to go and write code to customize the behavior of these objects.
Yeah.
What? I have to throw away all the stuff that I've written? Yes, you do. So guess what? A lot of people quit programming. I mean, I remember those times. So a lot of
I remember going from functional to object oriented, and I thought, this is so hard. And then all of a sudden I had a revelation. I'm like, I got it. But it's another paradigm shift, right?
So we rewrote all of our programs.
Yeah.
And fast forward, the internet is here in the 2000s, from 2000s to 2015. We spent time throwing away all the old code we'd written. Why? Because in order to access that code, even though it was nice and GUI, you'd have to go to the office, unlock the door, go sit behind your computer, turn the server on, and access your program. So I want to sit in my underwear and in my kitchen and use my program. So what you got to do, you got to have to rewrite everything with this new model. And now, actually, before in the old days, you and I could sit in our kitchen and write a program and distribute it on a disk. But now we need teams of back-end people, front-end people, DevOps. It's just the whole thing is completely changed. And we rewrote all of our programs.
Yeah.
And so what we're saying is this time is actually not going to be as painful and it's not going to take 15 years. It's going to take a few years. And we have a lot of automated tools to do that with, and once we know the paradigm, because the paradigm is very specific. It's about identification of objects. And actually, we filed quite a number of patents on this. And
great!
We're setting up webinars, and we want to give free licenses to people so they can actually experiment. And based on this, we built a project management system. We're focused on technology companies first, so software developers in the beginning, so they can get to feel and touch what this thing tastes like.
Yeah, no, I love the sound of this thing. I can't wait to start working with it. Is it available now? Can anybody just
it is. It is. We've actually, we finished our beta testing actually about a month and a half ago. And now we're kind of beginning to go to our launch phase. And we've kind of we actually used it ourselves because when I started in 2008, almost 2018, sometime or 2019. And we spent a couple of years trying to build a platform. And I thought, this is too big, too much for us. We're a small team. We're scattered all over the world. So we pivoted and started building a product to show people what this looks like. And also to solve a lot. And I'm actually quickly explaining this stuff, but there were a lot of these things were kind of unknown to us, and exactly what the object looks like. How do you actually organize the object? And yeah, well, of course, you need to have different channels for different classes of stakeholders. And what are these channels for? The channels, what do they hold? They hold communication, chat communication between stakeholders. What else do they hold? Anything else? Excel spreadsheet, a file, a link on the internet. Because if there's information about the object, what are the types of information you can keep? But you have to have separate channels for different stakeholder classes, because you don't want to talk to, the doctor and the patient have one type of communication, the doctor, the nurse have another type of communication, and the doctor and the specialist have another type of communication. And so this is how I actually solve the permission problem, because permission problem is it's a granular way of dealing with stakeholdership. So it really simplifies a lot of stuff, because now no longer when you create systems, I don't have to say, give Chris these permissions. I just say, well, Chris is a doctor, right, in the system. And then it knows exactly, oh, this is a patient. Or in our system, well, I just say, look, Massoud is a designer, but he's also developer. Or Chris is a project manager, or what we call them actually maestros. We call them project maestros.
Oh, I like that.
Yeah, because I don't like the term manage. Manage means that you're involved directly, but a maestro is a conductor, right? It's just the flow, just how it goes, and makes decisions. But any decision that you make, I could be hired, today, and I come into the company, I get in front of our system, and so a customer would call, and I have no training, I have no idea what anybody does, I've just showed up. But I know my job. Okay? I know my job. And I'm a customer support person. And I know these types of software. I get a call from a customer says, hey, I'm waiting for this feature when is that going to be released? I'll just do it like a Google search. And I find all these objects. And I actually look at them. Oh, is it this one? Oh, I see this one. I could query the objects. I could ask them, summarize everything about yourself. But and I could talk to it using natural language, right? And I see, there's been lots of talk about this thing. And I just say, hey, why are you delayed? And just come back and say, well, I'm delayed because blah, blah, blah. Now, when is you supposed to be, and that data actually is quite readily available on the screen. But if there's anything not available, I could query the object. Yeah. Just using natural language.
Yeah, because you can talk to it.
Yeah. And then from there on, saying, you know what? I'm interested in you. I'm going to follow you from now on. So what happens, and from there on, whatever happens to the object knows that, there's Massoud, who is a customer support person, and he's following me. Any event that occurs to me that is relevant to customer support people, I'm going to show up in his inbox, and I'm going to tell him something. This happened to me. But how do I know that any event that happened that's traditional programming? That's deterministic logic that needs to be coded by the programmers, right? So you end up with a 100% dependable system with no hallucination, and you take advantage of these large language models to give intelligence to these objects, and you assemble them together, and you have a super intelligent system that humans don't have to route information to, and don't have to worry about any message that they would get, whether should I read this or not, because you're guaranteed that if you get a message, an object, basically you don't get messages, you get objects that show up as a message. You're guaranteed that that's relevant. Either you've been somehow assigned that through the workflow, you've become associated with it, or you requested to follow that thing. So report to me. Right? So if you're a project manager and you assign me a feature, that the feature object shows up in my assignment box and says, hey, I'm here. You need to give an estimate for me. Right. Well, what do you look like? What are your specs? And I just query it. And I could see, there's an Excel attached to it. There's a graph attached to it. There's a whole document attached to you. And I read it. And I don't have time to read it. And I say, look, summarize this thing for me. Give me the highlights, right? So I, as a human, can interact with these objects in an intelligent way, right? That's why we make that claim.
Fantastic. Well, I'm sorry, but we're running out of time. This has been great. I mean, can you tell me more? Like, you didn't introduce yourself. So who are let's end with the introduction, and then you can tell us about how to get in touch with you.
Okay, my name is Massoud Alabash. I'm the co-founder and CEO of OMADEUS. You can look us up on OMADEUS.com. OMADEUS is kind of a play on words with Amadeus, which is Amadeus Mozart. And so we put it as OM because OM stands for object messaging. So OMADEUS is the OMADEUS.com. So www. Go on there, sign up for a webinar, try our product for free, and step into the new world. And don't worry about AGIs or sentience. You know, this will solve, and it's all optimistic. You know,
but you eventually, 10 years from now, this will have emerged into being able to manage the company for you, right? I mean, people can just sit on the beach and relax, well, that's the pathway.
That's the pathway. Just actually, you're running the right track, because once you go on this model, let's say you're a project manager, you're sitting there making decisions. You know, that's all you're doing. You're not writing in information, right? You're saying, go to backlog. I assign this to Massoud. Oh, this is low priority. That's all you're doing. I can actually put a model there, right there, and that's the next phase. And it watches you and learns from you. And then after 2 weeks, and says, Chris, just go home. I can take care of it. I know what you're. I know exactly. See,
I want that today, man.
That's the next step. That's the next step. Okay.
I love it. Well, thank you so much. This has been great.
Thanks for having me. Okay.
Talk to you soon. Bye.